if you're in a hospital, hopefully you're not, but assuming you are in the hospital and you're lying in the operating theater, then normally, for example, filters in the ceiling above the patient protect the patient from particles coming into the room.
Hello there and welcome to Let's Talk Clean Air, where we find out more about how clean air can affect the quality process for you and the workplace. This month we're taking a look at one of the most used acronyms in the industry, HEPA, to find out just what it is, how it works and why it's important. My name is Dusty Rhodes, and joining me to explain all of this is someone very familiar with HEPA. He has a 30-plus year pedigree with CamFil, where his responsibility includes all air filter products, the housing systems for them, and ensuring that they all run with the highest efficiency possible. In addition, as the German expert in the ISO standards for HEPA filters, he is part of the German and international standardization process for high air filtration purposes. It's a pleasure to welcome and to learn from Michael Feldtmann. How are you?
I'm good. Thanks a lot.
So every single program in the series so far, we've heard HEPA, 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 HEPA. What exactly do the letters HEPA stand for?
Well, it's, as you said already, it's an acronym, high efficiency particulate air filter. So you see high efficiency, that gives you the direction where we go. So very high efficiency to small particles, to protect sensitive processes, really to final stage protection.
And when you're talking about high efficiency, are you talking about it's particularly good at getting particularly small particles?
Well, if you want to understand how a HEPA filter is, let's say, being used and how it's working, it's a mechanical filter. So it has a very fine structure of a media, and the media itself is been made to capture very small particles on a very high level. So that's the idea, because the sensitive processes, which we come probably later to explain, the sensitive processes have to be protected. And that's what the HEPA filter or HEPA filters are for.
And how then does a HEPA filter then protect the environment?
Well, it's the environment. You have to understand that the HEPA filter is the final stage of an air ventilation system, right? You get the air into the building normally, and then you have a process somewhere in the building. Let's take life science, for example. You're producing, it's very actual, you're producing vaccines, for example. If you want to produce vaccines, you have to ensure that the production is being, let's say that the amount of particles in the room is very low, so that there is no effect on the product. So then you put a HEPA filter on the final stage of the air ventilation system to reduce the amount of very small particles to a level where you can produce. That's more or less in very short words. For example, for the pharmaceutical industry, when you look at the microelectronic industry, when you produce microchips, for example, then also small particles can affect the structure of a wafer, of a normal piece of electronic equipment. So that's where HEPA filters are used. That's one part, but also when you look at protecting the environment, what you mentioned before, like when you have laboratories, high advanced laboratories, the exhaust air of these laboratories are filtered with HEPA filters to protect the environment, to ensure that there is nothing coming out, so that there is nothing really coming out of the system.
That's something that I had never considered before. So you need to protect the air that is coming in, but of course there are things that could be happening in the facility, so you need to protect the air that is leaving the facility as well.
Correct. That is something which is really important also today in the actual situation, because, for example, if you have an isolation room, when you talk about people who are suffering, then you want to protect the other rooms or the outside so that nothing is coming to the next room or to the outside. So, for example, viruses are not coming into that room. So that's why you need also using HEPA filtration.
So is HEPA filtration something along the lines of where you would have a rough filtration purpose that would say capture 80% of particles, and then later on in the chain you've got your HEPA filter which captures the remaining 20%?
You could say it like that. I would say depending on the pre-filtration states you have. But when you look at the HEPA filters, you normally think about, okay, what is the efficiency on very small particles? That is because the filter itself is not like a sifter, but there are a few mechanisms inside the media which is collecting efficiencies. And all these collecting efficiencies together, they show that with a HEPA filter, you have a very high efficiency against very small particles. And then we are talking about not 80%, but then we are talking about 99.95% or even 99.995%, H14, and as a HEPA filter. So that is the difference, I would say, and you are then sure that the process afterwards is being secured.
So can you give me some examples, real-world examples of where HEPA filters are used?
Yeah, well, for example, if you're in a hospital, hopefully you're not, but assuming you are in the hospital and you're lying in the operating theater, then normally, for example, filters in the ceiling above the patient protect the patient from particles coming into the room, for example. Or, as I mentioned already, when you go to the pharmaceutical industry, even when you fill up glass vials with vaccines, these glass vials have to be sterilized. And here you have the HEPA filtration inside the sterilization tunnel. So the filter itself can be installed in the ceiling. For example, also in the microelectronic industry, when you produce microchips, as I said, these filters are installed in the ceiling. But also, and that is quite, I would say, new, or the idea is very common now, to have air purification system, transportable systems, also adapted with HEPA filtration to take them from room to room. So there are various applications, and you will find that also in the food and beverage is a good example also. When you look at your meat, when you look at the packages, it would say packed under clean environments. That is exactly what we're talking about. There's a HEPA filter in the machine to protect the product.
And how do we know that the HEPA filter is fit for purpose?
That is clearly regulated. You need to do 100% test of every HEPA filter before it is leaving the facility. And this test is being done with efficiency. So you test the efficiency. And with that, you test the filter class. And then you test that the filter is leak-free, because you can imagine of these sensitive productions, they need to be 100% sure that there is no leakage in the filter. And the pressure drop, for example, is also being tested while that. So you completely scan the filter. You completely check that the filter is okay, and you have an individual test certificate. That's where the, let's say, the quality behind it, that's where the end user has the security. The end user has the security that the filter is fit, that the filter is okay. And that's where the customer has to insist on. This has to be done.
I get the impression that a HEPA filter is to air like Fort Knox is to money. It's that level. Am I getting the right idea?
Well, Fort Knox to money, yeah.
Well, what I mean is it's very, 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 very high level. It is
very, very high level, and that's a little bit the problem we have today. That a lot of the customers, or not customers, a lot of the society is using HEPA in all different ways. They are saying HEPA filter, HEPA filter, HEPA filter. But when you look at real HEPA filtration, it is clearly specified. And if we are talking about HEPA, there is a standard behind that, EN 1822. So there's a standard really regulating what is HEPA and what is the performance and how you have to test it. So that's some of the let's say the societies using this for good filtration. But as you said, it's a very high filtration. So that you have to have in mind.
So how is the filter actually manufactured? How does it work?
You normally see a square or rectangular shape. You have a frame, and then you have a V-shaped pleated media normally. So the frame and the media filter pack, what we call it, is glued together. And then you might have a gasket on the filter as well. So the normal size is square or rectangular, or it can be even round, depending on the application. And the most critical thing is that the combination of frame, gasket, filter media is completely sealed. You can imagine that this has to be really sealed and according to the filter class you want to reach. So you can do, I would say, a lot of different variations fitting for the purpose the customer needs it.
Now, like anything in the world, there are various types of HEPA filters and various standards of HEPA filters. How do you compare HEPA filters against each other?
That's a good question. When you want to compare HEPA filters to each other, as I mentioned before, the test is being done at the production, after the production, before delivering the filters. And the end user, the customer, he cannot really check directly the filter class, because that's, you can imagine, quite a lot of investment to do that. The test certificate, the test procedures are not that easy. The end user can compare pressure drop of a filter at a given airflow. That's what he can do. And what can be done is to check in the installation what has been achieved. So if the clean room class is achieved, for example, that's what you can do. And when you want to compare different productions, then you have to insist, as I said before, on really 100% certificate, 100% proven quality. That's the background.
But who gives that 100% certificate?
That has been done by the producer of the filter. He has to do it normally, but we see on the market, as a lot of other things, we see someone who's not 100% following. But that's not what we are talking. We stick to the certificate, or to the standard, and that's what is being done by the producer. In this case, it could be Camphil. So you deliver that, and the customer, the end user, is then sure.
Should you watch out for to say that this is certified according to, and then look out for the ISO specification and make sure that is correct?
Correct. The EN 1822, so that is correct. And the customer has the security that what he's installing gives the right protection for the process.
And how dangerous would it be if you were to not go for a 100% filter and you got something that was 95% effective?
Depending on where you are. I mean, it's depending on in which application you're using the filters. Some applications, to be honest, there would be not a big difference, but depending when you are, for example, in a high advanced laboratory where you want to protect the people outside, there could be major difference, because 95% to 99.995%, that's a very big difference. So that's when you then imagine what is coming through can make the difference.
I'm trying to understand how effective they are, because for me, I'm thinking about the filter that's in my vacuum cleaner. And that obviously is not a HEPA filter, so we're talking something way higher. And then I'm also kind of thinking about the viruses as well. How effective are HEPA filters against viruses in the airstream? Because those viruses must be tiny.
Yeah, well, the viruses are very tiny, and take the COVID situation now. So we're talking about viruses which are in the range of 0.08 to 0.16 micrometer. So micrometer is a thousandth of a millimeter. So that's extremely small. On the other hand, when you see HEPA filtration is being measured and being tested, as I said, at the MPPS, so at the most penetrating particle size. And this particle size is in the range of 0.1 to 0.2 micrometers. So you can imagine that the HEPA filter, when you directly compare it, you would have an efficiency of 99.995% against these sizes. But you have to have in mind that a virus normally is connected to a particle or to an aerosol, in or at an aerosol. So then we are talking on probably sizes of 0.5 to 5 micron. But the efficiency then is much bigger. So we are talking close to 100%. You see, the HEPA filters is really protection against viruses, for sure.
They're very, very high-end, high efficiency. What I'm thinking is, how often should these be replaced? I mean, how long do they last?
Depending on the installation, you would normally talk about installation of, when you do a normal, let's say in the life science industry, you're talking about 5 to 8 years normally. But when you do, for example, when you use a HEPA filter inside an air purifier, where you constantly go through the HEPA filter and you have them installed in a room with not so good prefiltration, you might have 1.5, 2 years, 2.5 years. So depending really on the application.
That's a big difference. So how do you know, or how do you monitor the effectiveness?
The effectiveness in the normal installations, when you have a clean room, for example, the filters are being monitored every 6 months to a year, and the cleanliness level of the clean room is being monitored as well in that period of time. So you look, is it still working okay? That is one thing. And the second thing which you normally monitor is the pressure drop. So you monitor the pressure drop, and then you can see, okay, is it time for changing the filter? So depending really which application you have.
Well, speaking of changing filters, what kind of maintenance do you use a filter and do you just take it out and dispose of it when you need, or is there a way of conducting maintenance on the filter so that you don't have to be constantly buying a new one?
I think there are two things behind the question. One thing is that you normally dispose the filter into a bag, and then it is being disposed. Depending on where the filter is coming from. So when you're in a nuclear power plant, for example, and you have an exhaust, you would dispose the filter in a different way. That is one thing. The second thing is that because of the structure of the media, the media has a very fine structure, and this media, the normal media for HEPA filtration, cannot be cleaned. You need to change the filter. That is one thing. And on the other hand, if you think about how to clean a filter, and these filters are meant to be used against very small particles, and then imagine you want to clean it. That's tricky. You would normally destroy the media, and you would not take out all the particles. So to answer the other question is, no, you have to dispose the filter, and you are not cleaning them.
And what kind of other questions come up with people when you were talking to them?
As you mentioned a lot of them. I think lifetime, for example, is a big thing. Then what we already talked about, what are the differences? Where are the differences? How can I see, in brackets, differences? The last question is, well, I would say, or not last, but there's another question, okay, where can I install HEPA filtration inside my building or inside the application I have. Talking about viruses, what shall I do? What can I do? And in this case, you can upgrade the air handling unit, so the recirculating air, the air coming from the room. You could install there additional HEPA filtration. And that's most common now. When you do not want to do that, then you install in the room a HEPA air purifier. And that's more or less the main question nowadays, because the situation is a little bit different. A lot of, let's say, normal people like you and me are discussing and saying, okay, how can I put a HEPA filter in my
home? Yeah.
In my home or in my facility. So then you can use the HEPA air purifier, but you have to really insist then on that the filter itself is, as we already discussed, the proven quality.
And one final question. The HEPA filter, is it something that is installed into the existing air system within a building, or is it something that you can add on as an extra stage?
When you have an installation, when you have an air handling system, you can install filters in the air handling unit, but then you need to have a space to put that in. That's clear. If you don't have the space, you have to do an additional housing, which is then delivered with the filter. So you can upgrade that to that extent, and you can, when you think of the recirculating, you can also install filters. There are specific filters, but you need the space to do the space first. And what is a little bit more tricky is you need to have also the ability that the ventilation system can overcome the pressure. I mean, you are generating a pressure when you put this sort of filter in the system. So the system itself need to be capable of, doing the right thing, having enough air in the room. Otherwise, you would say that's not a good idea.
Excellent. Well, listen, that has certainly opened my eyes. Michael Feldtmann from Camfil, thank you for filling us in today.
Thanks a lot. Pleasure.
And that wraps it up for this episode of Let's Talk Clean Air. If you would like to find out more about HEPA filters, just follow the links in the show notes. You'll find those in the description of this podcast on your phone or whichever device you're listening to us on right now. They include links, contact details, and anything else that you might need to get more information. Our podcast was produced by Camfil, a world leader in the development and production of air filters and clean air solutions. To stay up to date on how clean air can affect the quality process for you and the workplace, do click follow or subscribe so that you will get our next podcast automatically. Until next time, from myself, Dusty Rhodes, thank you for listening and take care.